Alright, in this video what we're going to do is we are going to handle game create and game join. So let's start off with game create. I'm going to come down here. I'm going to say a.game_create, and it's going to take in a action. Then I'm going to say if not this is logged in, then this.fail action you must be logged in, followed by an early exit. Then I'm going to say let game. I'm going to say try game equals this, or sorry, lobby dot create game, passing a title of this dot name apostrophes game. Then this dot set handlers, new game handlers, passing in this and then passing in the game that was created. Then we'll say this succeed of the action, and then we'll say this dot succeed a dot game join game ID. So we're saying go ahead and succeed on the game create method, or action rather, and then go ahead and force the client to navigate to the game join, or the game screen, by passing in a game join event. Then I'm going to say catch E, then I'm going to say if game.dispose, then this fail action without an error message, and then throw E. So this is just cleanup. If for some reason we got an exception somewhere, we just immediately destroy the game, and then inform the client that we failed. And that's it for creating the game. So we should be able to hop on over into Chrome, or whatever browser you might be using, and then hit create game. And as you see, it actually goes and it sends us to the game. See, game 1. And if I open up another window and went to the lobby, you see that the game is right there. So, yeah. That's really it for creating the game. So now we'll do an a.game_join action. And what he'll do is he'll say if this dot handlers instance of game handlers and this dot handlers dot game.id equals action game ID, then simply pass in a success, so this succeed action, and then early exit. Then we're going to do const game equals lobby.getGameById, action.gameID. If not game, then this fail on action, and then say invalid game. And then return. And then finally at the end, simply this set handlers, new game handlers, passing in the game, or passing in ourselves and passing in the game, and then simply saying this succeed action. And that's how we're going to join a game. So now we should be able to come over here into Chrome, log in, create game, and we're getting an error, game does not exist. So let's log in, hit create game, and we're getting an error, game does not exist. But we are getting a game join, a successful game join. Now I think the reason it's doing that is because the step, what step are we on? Well, actually, we never even get onto the game. Oh, right. So what's going on is we're not hooking up the client yet into a player. So we're not actually joining the game yet. We're just setting the handlers. Inside of the game handlers themselves, that's when we're going to actually hook up into the game itself by adding ourselves as a player. So let's jump into our game handlers. And I'm going to go ahead and say this.onDispose. Then I'm going to say game.addClient, so the client is now attached and subscribed to the game. And then let's do two simple ones. I'm going to do say client.onRequest a game send message action. And we could validate here. We can say const validator equals validate message action.message. And then if validator did fail, then client.fail on action, and then validator.message, and then return. Otherwise, game.sendMessage, this.client, or just client, because that's in scope, action.message. Then let's go ahead and say client.onRequest a game set options. Action goes into, and then I'm going to say const validator equals game.setOptions. passing in the options that we want to set, which is simply action.options. And then I'm going to say client.respond action validator. So it'll send a success or a failure depending on if the validator worked properly. And then what I'm going to do is down here at the bottom of this constructor, I'm going to say if client.isLoggedIn. Remember, to join a game, you don't necessarily have to be logged in. So only if we are logged in, then I'm going to invoke this.onLogin. And then I'll implement this onLogin, which will simply be this.player equals this.game.addPlayer, this client ID, and this client name. And then I'm going to say this onDispose, and I want to do two things on dispose. I want to say this.player.addClient this.client. So the first thing I want to do is I want to hook up into the private view of the player object, so the client is aware of the hand, for example. And then I also want to add in this.player.dispose. So if this will do two things. When my game handlers are destroyed, they will both remove themselves from the client, from the game. They'll remove themselves from the game entirely. They'll unsubscribe from that. Then they will unsubscribe from the player object itself. Then they will destroy the player object. So this will remove the player from the game. And remember, when our socket receives a disconnect, we will dispose the client. So that's how that'll work. The client disconnects. Socket.io notifies us that the client disconnected, which comes down here. Then we get disposed as the client. When the client gets disposed, the handlers get disposed. And then when the game handlers gets disposed, then it will unsubscribe from the player, unsubscribe from the game, and then destroy the player. And that's it. So now, with that all in place, I should be able to reload both these tabs. And we see we get a cannot join game, invalid game. That's fine. Let's leave the game, let's log in, and let's hit create game. And now you'll notice that we get a merge view on view game twice. It appears. One sets the game to a particular thing, then the next one seems to be doing the same thing. And then we have our view lobby, which removes the players, it seems. Then we get our player view, and our player view simply has our hand and our ID and our stack. And then we get a successful game join. So now you see we're over here on the player list, and everything is awesome. If I come back over here to the other guy, and I hit leave game, he now has this, this game here. And if I had a third window open, let's go ahead and duplicate this tab. If I had a third window open, and then on my left window I log in, and then join the game, and I come back over here, we should see not what I'm expecting. We should have seen an addition. Oh, because the player the player names are the exact same. That's why it showed up like that. Let me go ahead and reload and use a different name, and then click on that. And it seems that we're still receiving that, but or no additional player here. We'll figure that out in a moment. We do, however, see that our players are being added properly here, and they also should be removed when I close this tab, and he is removed when I close the tab. And then when I leave the game, obviously it's still the same as it was, but that's to be expected. Because we haven't written any code saying when all the players leave, just destroy the game. We'll write that code later down the line. So let's figure out why the lobby isn't updated. So the lobby, we simply say games, this game's map, game summary. On game summary changed, we tick. And then on the game itself, when we receive a player, we do indeed push that on. So I'm going to put in some debugging here. I'm going to say console log hey. We'll do game ID, hey, then plus game ID. And so we'll figure out if that is working or not. So now if I create the game, and then if I have another player, a third player, watching me as I enter this game... Oh, now it's working. Huh. Okay, I'm not entirely sure what's up with that. Now, if I join a game and then log in, I automatically get added to the game. I can refresh, I can duplicate, I automatically get jumped back in, and then I can leave the game, and then I see that there. Alrighty, so I wonder if, because I didn't pass in anything into tick, an action into tick, oh, that's why. I need to invert this. What happened was, is my try and finally never got invoked because it was, if I sent in a null action, it wouldn't have this finally block, so it would never reset the inTick to false, meaning inTick would stay true. And the problem with that is if inTick is set to true, when it shouldn't be, the actions are never going to be invoked, and they're just going to short circuit. So that'll fix that bug. The only reason it started to work was because I added an actual debug statement to it. Don't you love those bugs where you know there's a bug somewhere, and then you add in some sort of diagnostic, and then by the act of adding in that diagnostic, the stuff starts working again. One of the most frustrating classes of bugs, in my opinion. Anyway, let's go ahead and move on. So, let's jump into our game. And I don't think I am setting the step, but I misspelled that. You guys probably caught that. So if I go ahead and do that, and actually set the step properly, we should be in the setup step. So we should be able to see the options, and we do. So when I start the game now, or create the game now, we have our options, and I should be able to change the options. As you can see, we're sending the set options request, then we're getting a merge view, which updates the options, then we're getting a game set options success. So as you can see, we can change all the options. Now, hitting start game doesn't do anything yet, but setting the options does work. So, we're getting pretty close. There's one more class that we're going to have to write and stub out, and that's a helper class that's going to be helpful for a bunch of different game-related operations. Then after we do that, really all that's left is finishing our game class, finishing our player class. Whoops, I'm in the stores, aren't I? Finishing our game class, finishing our client handlers, and finishing our player class. But in this video, I'll just wrap up this video implementing the round real fast. So I can do that really quickly. In model, I'm going to go ahead and create a new file called round. And round, well, there'll be a new round instantiated every round that happens, of course. And it's going to contain a bunch of, it's going to contain a lot of the game logic for dealing with stacks and showing and revealing stacks and so on. So we're going to import Lodash and we're going to import shuffle. And then we're just going to do this method from top to bottom, or do this class from top to bottom. Export class round. It's going to have a view, though it's not going to be a room. It will have a view. And I'll have a black card, which is going to be this dot black card, and then a stacks of this stack list map. S goes into this get stack details S. So we've already seen how the round view will look because we've written the client code for it. So get ROL stacks finished will return underscore every this dot stacks. S goes into s dot player equals this dot zar, or this is stack finished S. So if every single stack that isn't from the zar is finished, then return true. The constructor will be black card zar players. We're going to say this dot r stacks revealed. So can, or equals false. So can other players see stacks that aren't their own? This black card equals black card. This zar equals zar. This stack list is new array. Then let stack ID equals null. We want to preemptively create a new stack for every player that's currently playing in this round. So this dot stacks is going to equal players dot filter. P goes into P does not equal zar. Dot reduce. And the reduce is going to have a obj and a player. And we're simply going to return ID is stack, or sorry, we're going to say stack ID plus plus. Then I'm going to say ID is stack ID. What am I doing? Cards equals empty, and then player. Actually, why am I returning this? I should instead say object at stack ID equals, and then return object. Basically, we're taking an array of players and we're constructing an object out of it. Be sure to pass in the second blank argument into reduce, the empty object. Then we're going to write a method called getStack, which will be stack or stack ID. We'll return Lodash is object, stack or stack ID, followed by stack or stack ID, or this dot get stack by ID, stack or stack ID. Then I'm going to say get stack by ID, return this stack's ID. Get stack by player ID, return Lodash dot find this stack's s goes into s player ID equals player ID. Again, these are just a bunch of different helper methods that'll make we'll make writing the rest of the game class a lot easier. Then add card to stack. We'll take in a card and then a stack or a stack ID. I'm going to say const stack equals this get stack, stack or stack ID. No, this get stack. Looks like I messed up my capitalization there. Then I'm going to say if stack.cards.length equals 0, then this dot stack list push stack, followed by stack cards push card. So the stack list is an array of the stacks, and that's so. And then the first time you add a card to a stack, the stack gets pushed onto the stack list. So that way, when people are playing, the stacks will be added sequentially from the first person who played to the last person who plays. Then I'm going to have get stack details, which will take in a stack or stack ID and a force reveal of false. Then I'm going to say const stack equals this dot get stack, stack or stack ID. Then return force reveal or this r stacks revealed. Question mark, ID is stack ID. Cards is stack cards slice. We have to copy it. And then is winner is going to be stack equals this winning stack. Otherwise, simply return ID is stack.id followed by count is going to be stack cards length. All right, so then reveal stacks is simply going to say this r stacks revealed equals true, and then shuffle this dot stack list. So make sure that it's very difficult for people, or people won't be able to tell whose stacks are whose based off which stacks appeared first. Then select winner is going to be stack or stack ID, and it'll simply say this winning stack equals this get stack, stack or stack ID. Remove stack, we're going to have stack or stack ID, const stack equals this get stack, stack or stack ID. Const index equals this stack list index of stack. If index does not equal -1, then this stack list dot splice index1, and then delete this stack's stack.id. Has player played will be player or player ID. So this is has the player finished playing. So const player ID equals is object player or player ID question mark player or player ID dot ID, otherwise player or player ID. Then const stack equals this get stack by player ID, player ID. Then if not stack, then return false. So if that's an invalid stack, return false. Otherwise, return this dot is stack finished stack. Then is player playing. We'll have a player or player ID. This will simply return if the player is in the round at all, or if he's just a spectator for the round. So const player ID equals is object player or player ID question mark player or player ID dot ID. otherwise player or player ID. Then constack equals this dot get stack by player ID, and then return stack or not this is stack finished, stack otherwise false. And the final method we have to implement is stack finished, stack or stack ID, and we're simply going to say return this dot get stack, stack or stack ID, dot cards dot length equals this black card dot white card count. So that should be pretty self-evident. If the stack is finished, that means the length of the amount of cards in the stack equals the white card count. And with that, we'll see you guys in the next video.